Next, students, we will be understanding the concepts of how to evaluate machine learning models, because next we need to solve the problem on evaluation of machine learning problems. So before that, we should understand what is that basic concepts we need to understand when we have to evaluate the model. See, the first to understand, there is a concept of evaluation based on data split and how data can be reused. Based on that, we have three different methodologies. One is holdout methodology, cross-validation methodology, bootstrap method. So basically all these three methods is been categorized based on how data is split and how it is reused and what kind of data set is being used. In the case holdout, it is a simple split of data. Split and train. So here in the case of holdout methodology, very simple split is done. When the large data sets is there, we need to go with holdout methodology of evaluation. Cross validation is something where multiple splits will happen when we want reliable evaluation, when the data sets available is very limited. Bootstrap, here the data set sampling with replacement is done. Basically, when the data sets available are very small, this kind of methodology is evaluated, and for identifying the uncertainty in the model, we go with bootstrap methodology. So these are the three different methodologies where the evaluation of machine learning models can be done. Suppose in cross validation, we have the methodology called k-fold. That is, the data set is divided into k parts. First, the training is done on, or training is performed on k-1 data sets, and testing is done on remaining folds. So this is something, a theoretical concept which is actually needed to solve problem. Next, very important concept when it comes to the problem is confusion matrix. So we should understand what is this confusion matrix. This confusion matrix is nothing but a table which is used to evaluate performance of classification model by comparing between actual value with predicted value. See, this is how the format of confusion matrix is. We are comparing two different value, that is actual value and predicted value. The table goes like this: actual positive, actual negative. With respect to predicted positive, predicted negative. So the value we are representing here is TP, FN, FP, TN. Basically, TP is true positive, false positive, false negative, true negative. Why I have written like this? Because this is how we represent the confusion matrix. The format is actual positive record, actual negative, predicted positive, predicted negative, and we are going to represent these values. This is finally known as confusion matrix. Now in the problem, if the question is given to you, certain data set is given, you need to represent the data in terms of confusion matrix. Let's take one example and do. Let's assume there is one medical report being generated, okay, where in this medical report it says that TP is 30, FN is, that is false negative, is 10, false positive is 5, and true negative is 55. These are the data which is available. Now let's understand how to understand these parameters and put them back in this confusion matrix. Now let's take an example. There is a report where we need to predict following these values. One by one I'll explain you. TP, true positive. In the case of true positive, the model will predict positive class. That means simple. It is going to predict actually when the person A, let's assume that A as a person, and person A has the disease. He has the disease, hence the report is positive. Always TP, that is true positive, will give us the measure of actual positive class. Person A actually is having disease and hence it is predicted. True negative. In the case of true negative, actually the model will identify the negative class. Actually, if the person A is the one who is having the disease, if he is actually having the diseases and it has been predicted, we call it as true positive. And if the person he doesn't have disease, that means report came negative. Therefore, the prediction is A is healthy. This is true negative. Yes, the test is negative, person is healthy and he is not having any diseases. Therefore, this is true negative. So if you understand actually what is true positive and what is true negative, it is easy to understand other two parameters. False positive. Model will incorrectly predict the positive class. It is doing the wrong predictions of the positive class. Means what? Suppose there is a person B. Okay, the person B is healthy. But for such person, it is giving wrong as a positive. Positive means what? Whenever a person is having the diseases, he is predicted as positive class. But in the case of false prediction, what is happening? It's a wrong prediction. Person B is like healthy, but the false positive is indicating that, or it is predicting that disease. So this is known as false positive. Next is false negative. Incorrectly predicting the negative class. We already know what is the negative class. That means the persons are basically getting the test as negative. That means they are healthy. Actually, person is healthy, but it is giving the wrong negative class. It is predicting it as negative. That means it is predicting that even though person is having disease, it is predicting as healthy. This is known as false negative. So you should understand one sensitive part. True positive. Yes, report is positive, person is having disease. True negative. It is predicting it as a negative because he is healthy. Report says he is negative. But in the case of what is happening in false positive and false negative, even though the person is healthy, it is indicating as disease. That is, it is considering this person into positive class even though he is healthy. Even though person is having disease, he is actually affected. But in the report, it is predicting as healthy. That means it is indicating false negative. So these two things which actually reflects this. False positive is giving wrong version of true positive. And it is indicating the wrong version of true negative. That means person is actually affected, but person is being predicted as healthy, showing that the report is negative, but actually supposed to be positive. That is why it comes under false negative. So when you understand this true positive, true negative, false negative, now based on this, when the report is given or the data set is given like this, now let's analysis this based on this. True positive 30. What does it mean? It is actually predicting the positive class. That means 30 members are affected or the 30 members are deceased. It is giving correct prediction as positive. False negative 10. Actually, it is indicating it as false negative. Actually, it is giving the prediction as 10 people are healthy, but it is wrong. These 10 people is being false negatively projecting, because false negative says what? Incorrectly predicting the negative class. Negative means even though this 10 members are deceased, but it is giving the false negative report as these 10 members are healthy. Next, false positive is 5. So what false positive is doing? It is predicting as disease even though they are healthy. That means it is trying to give the positive class. Positive class means report is positive, he is affected. Like that, even though they are healthy, it is predicting as diseased. That is false positive. These 5 people are predicted as deceased, but actually they are healthy. Last true negative, that is Out of this data, 55 members have got the report negative. 55 members are actually non-deceased. When you analysis this and you know this is the way to put the confusion matrix, let's update back this in this format. So this format plays very important role. How much is TP? 30. False negative 10. False positive 5. True negative 55. Now it is very, very important to understand the relation between true positive, true negative, false positive, false negative. I make it very simple now. When person is reported or is actually having the disease and is being predicted as deceased is true positive. And the person is healthy and also he's been predicted right as healthy is true negative. Person actually he is healthy but predicted as disease is nothing but false positive. A person who is actually deceased but predicted as healthy is false negative. So when we have this kind of report, now how to measure the model or evaluation, or when we have to evaluate this kind of model, we need evaluation metrics. Metrics are the various parameters that can check the performance of the model. So the various evaluation metrics is accuracy, precision, recall, F1 score. So now all these things in upcoming problem, we will be constructing confusion matrix. We will be finding this matrix where the clear formula will be given to you. Now I'll just quickly explain what is this terminology. Accuracy, overall correctness means actually how many actual deceased people were identified as actually deceased. That is something which is called as overall correctness. Precision, correctness of positive predictions, where we are identifying the correctness of positive prediction. That means it should not cover false positive. Okay, something which is going to avoid, the precision is going to avoid false positive. What is that false positive? Even though people being healthy and predicting them as a deceased, something which has to be avoided. That is known as precision. Because I'll give you an example of spam. Spam, we want actual unwanted messages has to be detected as spam. Somewhere else where important official mails should not be labeled as spam. So that is how the precision is measured. Recall, it is ability to find actual all positives. So precision is something which will avoid false positive. Recall is the matrix which avoids false negative. What is that false negative? Even though the person is deceased and predicting them as healthy. This is known as false negative, right? So avoiding this, avoiding predicting as a deceased person as healthy is something what recall will avoid. So recall will avoid false negative, precision will avoid false positive, and the last is F1 score. F1 score is the metric where it will try to balance both precision and recall. So these are the parameters where we have to measure to evaluate the machine learning model. Next, when we take up the problems, it will be more clear.